Live on WFLA Now. With a specialized degree in climate, Chief Meteorologist and Climate Specialist Jeff Baradelli is pioneering the way we look at climate and extreme weather. Welcome to Jeff's Climate Classroom, powered by ArmorView Window and Door.
Hey everybody, we have an exciting episode for you today. We're talking about off the charts. Earth vital signs are going haywire. If you've been paying attention to what's going on Earth right now, lots of the indicators of climate are flashing red right now. We're going to be going through each one of those and talking about what that means and what is causing that. I want to welcome you to Climate Classroom. You can listen to us and watch us on WFLA.com. Also, once the show is done, we post this on YouTube, and you can also listen to it on Spotify as a podcast and also on Apple Podcasts as well. I want to welcome you. I'm Chief Meteorologist and Climate Specialist Jeff Baradelli, and I want to introduce my guests for today. First, Dr. Michael Werner. He is the Senior Scientist in the Computational Research Division at Lawrence Berkeley National Laboratory. I've known Dr. Mike for a long time. Thank you for joining us for the show.
Well, thank you for having me back, Jeff.
You're welcome. My pleasure. And also Val Simpson. Val, you might recognize her. She is part of our WFLA weather team, and you can watch her weeknights, Monday through Friday at 9 p.m. on Noticias Tampa Hoy.
That's good.
Val, thank you for being here.
Thank you, Jeff. It's a pleasure. Hi, Dr. Michael. It's a pleasure meeting you. Thank you for your time today. I have one very important job, and that's going to be... You were gonna get set. I'm sorry. I'm getting ahead of you.
No. That's exactly what your job is, to keep me in check. Val's job is to smack me down. And Dr. Michael, I hope you don't mind, you too, when we're speaking over people's heads and we're not talking to the audience, okay?
Yes, that's right.
And she's here to ask any interesting questions that come to mind.
Yeah.
Okay, so I want to start with the heat wave, because that is the biggest issue here in the Tampa Bay area right now. It's been a huge issue for the past 2 to 3 weeks across Mexico and Texas. So Dr. Michael, can you put this into context for us? Just how big of a heat wave has this been for Mexico and for Texas? And then we can talk a little bit about how it's going to affect us here in Florida as well.
Well, it's a very serious heat wave and a very dangerous one, not just because it's hot, but because of the high humidity. And that makes it dangerous in a couple of different ways. One of which it doesn't cool off at night as much as it might otherwise. The other is your body cools itself by evaporation, by sweating. And as you sweat and that evaporates off, that's how you cool yourself. If it's humid, that process doesn't work as well. And so the people who are particularly vulnerable, the very old, the very young, and the very ill, can have all sorts of problems from this kind of these kinds of temperature and humidity combinations. And so that's what concerns me most, is the health of the people impacted.
You know, for the folks at home, we are going to be seeing some pretty harsh heat and humidity here in the Bay Area as well. But it's not going to be anything to the degree of what they saw in especially Mexico and also in Texas, just to let you know. The graphic you're looking at here, Michael, is obviously North Atlantic sea surface temperatures. And I want to give a great shout out to Professor Elliot Jacobson. He's been producing these great graphics on Twitter. But this is interesting. Looking at the North Atlantic Ocean temperature there, wow. I mean, look at how far above normal and how far above records it has spiked so far this season. And by the way, as you know, Dr. Michael, this is not just the Atlantic Ocean. We're seeing record global temperatures, and not just by a little, by a lot. So can we talk about what the reasons for this are, both climate change and also some of the natural reasons as well?
Well, you know, that the histogram picture makes me afraid of Val's buzzer, because it's a very interesting plot from when I'm wearing my statistician hat.
Val, can you go back to that one graphic for him? And JB, can you take it full?
And the reason it's interesting is it's what we would call an outlier. You know, it's very far away from, very much larger than any other temperature on that graphic. And that makes it challenging for us to understand and for us to use our statistical techniques to infer how rare an event it is. And in fact, there's a very good chance, I haven't done the analysis on that particular time series, but there's a very good chance that that event is statistically impossible. And it's almost certainly statistically impossible without climate change.
But
the problem is it may be statistically impossible with climate change, which then tells us that there's something wrong with our statistical models. And this is what happened in 2021 with the Pacific Northwest heat wave. And we are just about ready to submit our paper that takes our, I would say, simple statistical models, but 20 years ago or even 10 years ago, that would have been an extremely state-of-the-art statistical model. And we finally, I think, have got enough, I have enough bright statisticians working with me that we can actually deal with these kinds of outliers. But it's a very challenging mathematical problem. And so, there's a lot we know about climate change, but nature, right now in this picture alone is throwing scientists a curveball, and we got to see a bunch of curveballs before we can hit them.
Yeah, so, I think that it paints sorry, excuse me, I'm sorry to interrupt.
No, Val.
I was going to say that.
Val, you're the one with the buzzer. You're the one with the power.
Yeah, no, I was just going to say that not only for scientists, I think that this chart right here illustrates a huge jump. It's a visual for mainstream folks to look at it also and say, wow, look at that. The jump is astronomical. I mean, just by looking at the chart, right?
And what Michael was talking about is statistical impossibility. So historically speaking, to get a jump like we see at the very end of that chart, and we can't actually see it because it's slightly cut off there. But some people have done the math, Michael. Brian McNulty from University of Miami did the math, and it's something like 1 in tens of thousands of a chance that it could happen in the North Atlantic. Doing the math for the global ocean temperatures are so far above records that it's a 1 in over a million chance. So basically what we're saying is it's virtually impossible before climate change. Actually, you know what? That's not true, Michael. Let me rehash that again. What I was speaking about for the Atlantic Ocean, I'm pretty sure is 1 in like a 30 or 40,000 chance of it happening in a climate that is normal from 1980 to 2010. Mm-hmm. But trying to go back to pre-industrial, that makes it something like 1 in a, no kidding here, according to Brian McNulty from University of Miami, like 1 in a trillion chance. So it's basically not possible to have ocean temperatures really around the globe and specifically in the Atlantic without warming from humans since 1900.
So I'm really at risk of the buzzer here now, but the way that we look at these kinds of statistics is something called generalized extreme value theory, and the beauty of that is it's an asymptotic theory. I'm sorry, no, the buzzer didn't come.
Wait, Val, can you just do me a favor, Val? Where's the buzzer?
I'm buzzing.
Go do it again. Let's hear it again.
No.
Let's see, it didn't. So
I didn't hear it.
What do you mean?
We don't hear it. We're not buzzed.
Dr. Michael, are you listening to this buzzer? Can you hear this?
We can't hear it.
What do you mean you can't hear it?
I have not been buzzed. I have not been buzzed yet.
The buzzer doesn't work on it. How is it not possible the buzzer doesn't work on air?
Because what I have to say is really important.
Let me see.
So the point is, before the buzzer is that these kinds of specialized statistics are we can actually calculate what an impossible temperature is. And I think that's really interesting. The question is, we can calculate what's impossible in the past. We can calculate what's possible now with climate change.
Yeah.
And then if we exceed that, then that's telling us something is it's telling us one is very unusual, but it's also telling us that things are happening that we don't always fully understand.
Yep. Yeah.
And that's the beauty of climate change science, if there is any beauty in something that's really actually so horrible, is that it's really scientifically challenging and very interesting. And so some geek like me, grooves on this kind of stuff because it is hard and
expect the unexpected, I guess is what we should say.
And then after when the unexpected happens, try to explain it.
Right.
And so that's what we're challenged with.
Bringing it back to the surface sea temperatures, and for us right now here in Florida, we are right in the in hurricane season. How are these temperatures affecting us in terms of what can we expect for this hurricane season? Because we all know that waters that are very warm are like gasoline for systems developing in the Atlantic. So how does that play a role? What is it that we can expect?
Well, it's true that it's the high temperatures in the ocean that provide the energy for intense hurricanes and tropical cyclones. But we're also entering into an El Nino phase of the state of the ocean, and it's oftentimes El Nino years are less active in the Atlantic hurricane season, as Jeff well knows. But there are other factors at play, and this will be an interesting year because of these really high temperatures, and also interesting because of the smoke. We know that dust off the Sahara can suppress hurricane formation. That's actually really low this year, and then we have all this smoke that you're seeing now in this animation. And, quite frankly, maybe Jeff has some ideas on this, but I don't actually know what that would do if this smoke is then advected into the main hurricane development regions.
I mean,
it's a different altitude than, say, the African dust.
I do not know that answer. I'm not sure we've ever had to answer a question like that before. I mean, what's amazing about that graphic right there is, and this is our next subject matter, so we might as well just transition into it, Canadian fires, and how out of whack it is that they have a record fire season in terms of the number of fires, the intensity of the fires, the size of these fires, and the amount of emissions that are coming from the fires. But Val will play it for you again. Look at this connection of smoke because of the steering currents across the North Atlantic going straight across the North Atlantic and into Europe. So Europe's skies are hazed over and clouded over due to thick smoke as far as Italy, which is pretty insane. So yeah, your question is a good one, right? If that circulates back around, and there are indications that it may be, you can kind of see on the bottom of the screen there that it kind of circulating back into the Atlantic, does that act as particulate matter, kind of like dust? I don't know if it's ever going to be enough to really make a dent, though. So I don't think it's going to, I just can't imagine it having much of an impact. But what I can say is there truly is, as Val was talking about, a behemoth struggle this year, and Dr. Michael too, a behemoth struggle between what is going to be a strengthening and possibly a strong or even super El Nino later in the season, and extraordinarily warm water temperatures, way above anything we've ever seen before. They're going to be duking it out to see which one can come out the winner, whether we're going to see less storms or more storms. I think all bets are, and we're betting and hoping that we're going to get, that if we do get more storms in the Atlantic, and we should because it's so warm, that we will see the strong wind shear kick in and cut these storms off at the knees before they get to the U.S. Yeah. Of course, at any time, a storm or two could sneak through. That's, of course, the problem.
So I have a question, because last year around this time, we were talking about Saharan dust day in and day out, and we were talking about those plumes coming into and helping us out and giving us beautiful sunsets. But what's happening right now? How come we haven't seen that or as much?
Well, I can jump in real quick. So we've seen a very weak, what we call Azores high, so big high in the central Atlantic, which usually steers hurricanes towards the U.S. mainland. It's been really, really weak, and so the trade winds have been very weak. And when you have weaker winds at the surface, there's less winds to kind of stir up the dust across the Sahara and push that dust into the Atlantic. And Michael, I think you're probably aware of this. NOAA put out a study a couple of years ago saying that as the climate changes, we do expect less African dust in the deep tropics of the Atlantic Ocean.
Ooh.
Yes, and my colleague Kevin Reed and I have a paper looking at the effect of African dust on hurricanes, and of course, if there's a lot of it, then it suppresses, and if there isn't, then it doesn't. And so we have a lot of different things going on this year,
right,
in terms of the hurricane season. So, and you're right. In some sense, we have multiple things that have never happened alone, and now are happening together.
Yep.
So this is again the buzzers. This is what we call a compound event, or a compound situation where lots of things are happening at once, all of which are kind of interesting.
Val is buzzing us, although we can't hear it. The folks at home, I bet, can hear it, but we can't hear it on IFB. That's a problem.
That's why you can't hear it on the IFB.
I bet you that's what it is.
Here's something that I have a question, something that I'm worried about, because you're both saying that we're going to see less and less Saharan dust. And I don't know, are ocean temperatures going to cool off anytime soon? Are we going to see them cooling off? Because if we're going to see less dust and higher ocean temperatures, what does that mean?
Well, we might or might not see less dust, although the latest research says we probably will in the future. Less dust means more sun gets through, and that means the ocean waters warm up. I think it accounts for something like 30% or so of the tropical sea surface temperatures, the amount of dust you have, But ocean temperatures will keep warming. There's absolutely no doubt about that. As long as we continue to burn fossil fuels, we continue to release carbon pollution into the atmosphere. And I'm sure Dr. Michael can back me up on this.
Well, yeah, I mean, it's kind of a no-brainer, and there's documented evidence that that the most intense hurricanes are becoming more frequent, and so across the globe, maybe in the Atlantic. Can we talk about the smoke and health?
Yeah, let's do that. And Val, let's go from this smoke graphic to the next chart, because again, the headline here is off the charts. There's so many off the charts things. Look at this chart. Look at 2023 in the purple in Canada, and then look at every other year. So go ahead. Let's talk about the impacts of this smoke and on health as well too.
So is this Eastern Canada or all of Canada?
This is I think it's all of Canada.
Oh, that's interesting. So, the question I was asked today, did climate change cause these fires? And that gets into the whole attribution science question about what does attribution science do? And what I like to say is that, complex events have complex causes. And so it's not unlike when you go to the doctor and, they say you have this disease and you say, well, what caused it? And it says, well, I'm a smoker and I'm overweight and I have a family history,
Yep.
So all those things contribute. And so when we look at weather events, climate change is just one thing that can contribute. So that being said, I'm not aware of studies on Eastern Canada. And one thing I am sure of is that the contribution of climate change varies a lot by region. Not just the climate change varies by region, but the forest is different in the Eastern Canada than it is in Western Canada, which is where the fires in the previous years have been. And that's where the studies are. One of our young scientists, Megan Kirkmeyer-Young, wrote about the 2017 British Columbia fires, that the burned area was increased by a factor of 7 to 10, which is an enormous
climate change.
Yeah, from climate change. And
well,
then a recent paper on California fires that looks at the trend in burned area concludes that nearly all of that trend is attributable to global warming.
Yeah, that's pretty amazing.
Results.
You don't normally get that kind of attribution, but that's California. Just to speak of Canada specifically, this year we've had this big heat dome sitting over Canada this whole year so far. Especially central Canada, not so much eastern Canada. And the fires have been horrible in British Columbia, and especially in Alberta as well. So this is, all of Canada that's sharing in the fires this year. And also we should talk about this, Michael, which is Canada's wildfire emissions are now at a record level. In fact, equal to that of Canada's normal emissions of greenhouse gases in a given year. So even if Canada had zero emissions, even if they said tomorrow, we're going to ratchet down emissions to zero, which you could never do, but if they were able to, the unfortunate situation is with a warming climate and seeing more fires, or at least fires that burn more acres, we're getting the equivalent amount of emissions emitted into the atmosphere anyway. Unfortunately, counteracting the emissions reductions of countries in the future. So it's just, I think, an irony that we may have to deal with to some degree.
It is, but that's not what worries me. Canada's emissions are a small fraction of the U.S. emissions, and an even smaller fraction of China's emissions. And it's not that it's unimportant, but these are the global problem, the emissions, and so I don't want to point the finger at Canada.
No. I totally understand that. I just thought it was interesting, and we better move on to the next topic, just because I think we're done by like 3:15 or so.
Yes.
Yeah. So now in Antarctica, and I'm sure you've seen the visualizations on on social media, and it is just incredible how big the sea ice anomalies are around Antarctica. So essentially the departure from normal in record territory, matching that of 2016. So of course there's the question of, we have an El Nino now beginning. That was during an El Nino as well. So I wonder how El Nino kind of affects sea ice in the Antarctic. But I think, Michael, if you want to chime in about the degree of anomaly here, and I realize that neither one of us are Antarctic sea ice experts here.
Yeah, I see this picture and it's just like weird.
It's jaw dropping.
It really is. It's important to remember it's also winter there. And so, that means something about, this is a very unusual Antarctic winter. And it's hard for me to say much about it.
Yeah.
Sure that.
I have a question. What does this mean to wildlife? What does this mean to wildlife? Where are they going to live?
It's a good point. Penguins are a good example of that, right? So there are certain wildlife that need ice to survive. There are not polar bears in Antarctica. There are around the Arctic. But I can't answer the question about wildlife beyond that standpoint in Antarctica, because I'm certainly not an expert at all. It obviously would cause some problems. But here's another visual, which I think is even better, by the way, which shows the average person just where we're losing ice and where we're gaining sea ice this year. So far this year, look at all the red. Wow. So basically the whole continent. Wow, and it's just one of the off the chart charts that scientists are staring at and saying, what is going on? Now, I want to say this one thing. Climate change is obviously underlying a lot of this, but on top of it, as Michael has pointed out, we have a lot of other things compounding on top of that. That's the reason these spikes aren't being caused by climate change. It's climate change here. And then on top of that, all these things that are lining up at the same time.
Does El Nino have something to do
with it?
But
still, it is shocking. That's right. So that's another thing I should mention. We're going to see crazy, crazy, crazy stuff that's even going to, astonish scientists this upcoming year. And a lot of it's going to be because of the extra jolt of energy on top of climate change from El Nino as it gets more intense. So thank you, Val, for talking. This is exactly the point that I was about to get at. And I'll let Michael kind of get the last thought on this, and then we'll probably have to wrap up the episode.
Well, the Antarctic sea ice is very different than Arctic sea ice in that a lot of it is not permanent sea ice. It comes and goes, and so it's not as thick as, say, the Arctic permanent sea ice. And this is all very interesting, but of course, it's not the scariest thing about Antarctica, which is actually the land ice, right, and the stability of the land glaciers. And if some of those, and there are scenarios where some of those could collapse and then fall into the sea, and then raise sea level by substantial amounts, which would have very serious impacts for most of Florida.
Right.
I do want to say that I'm sorry, because I'm just realizing that once we went through Canada and now Antarctica, and we're looking at all these graphics and the effects that it's having, being an El Nino has its benefits, but it also has its negative side on what it's causing in terms of the high ocean temperatures. It benefits us on one hand because it does promote those wind shears, and it does promote, especially for us at home, for hurricane season, right? But then on the other hand, we're seeing this in Antarctica, which is, it's worrisome.
Go ahead, Michael.
In some sense, there's nothing we can do about that. I mean, we're going to have El Ninos and La Ninas forever. That's just part of the natural variability of the climate system. But what we do have control is how much global warming we're going to have. Mm-hmm. And that depends on, what we decide to do with our consumptions of fossil fuels
there you go.
Yes. And that's something we do have control over.
Mm-hmm. Mm-hmm. Yeah. And I think we'll probably end on that note. Val, anything else that you think we left out in this episode that we
I do want to mention one more thing. There is a great article that Jeff wrote on our website, WFLA.com. If you guys want to learn more about this topic, it's extensive information. You'll be able to find all the graphics that we explained today, so you don't want to miss out on that. And yeah, that's all I have.
All right, Val, thank you for promoting my article. There's a lot more information in this article that you can read about. And this is something I don't think is going to be going away this year. I think we're going to have a lot of opportunities to talk about all the extremes this year. When you take climate change, which has, certainly we've seen temperatures rise a lot over the past few decades, especially. And then you add on top of it this natural variability due mainly to El Nino, but there are other things going on as well. We're going to reach extremes that we have never seen before in this upcoming year, or at least never seen in modern history before. And I'll leave you with that view right there, which is the heat dome, which is, of course, most pertinent to us here in the southeastern United States. The good news with this is it's going to be, this heat dome is going to be dissipating and weakening over the next several days, but we're in for certainly some very hot weather over the next couple of days. Dr. Michael Werner, I want to thank you for joining me.
Thank you very much for having me.
And Val Simpson, thank you for helping me out today. I really appreciate it.
You're very welcome. My pleasure.
We're going to figure out, I can't hear it. Hopefully people at home can hear the buzzer.
We're going to finish with the buzzer. That's it, because we're running out of time. JB's telling me that we got to wrap, so we're ready to go.
Bye-bye, everybody. Bye-bye. See you next week.
Watch or listen to Jeff's Climate Classroom, powered by Armor View Window and Door on WFLA social media platforms, and find Jeff's climate reports on WFLA.com.